10.1 Triangles. For this lesson, we're going to learn how to solve problems involving triangles. First, we're going to learn how to classify triangles by sides. If three sides of a triangle are congruent, then we call that an equilateral triangle, meaning all sides are equal. And for an isosceles triangle, we have at least two congruent sides. For a scaling triangle, we have no congruent sides. To classify triangles by their angle measures, for an equilateral triangle, we need to make sure that all angles have the same measure and have a 1:1:1 ratio. So if I have an equilateral triangle, I need to make sure that all these angles are 60 degrees. Just for your information, the total sum of angle measures of a triangle is 180 degrees. So for an equilateral triangle to be equiangular, each angle has to equal to 60 degrees. So 260, so that's 1, 1, 2, 1, 2, 1. For an isosceles triangle, the opposite angle measures of equal sides are equal. So x is degrees is equal to x degrees. The third angle measure can either be acute, meaning less than 90 degrees, a right angle equal to 90 degrees, or an obtuse angle greater than 90 degrees. So let me draw a picture for you. So in order for the isosceles triangle to be an acute triangle, we can have two sides equal, and this angle is less than 90 degrees. Or we can have two sides equal, and this is 90 degrees. Or we can have two sides equal, opposite sides equal, and this angle should be greater than 90 degrees. Okay, and the same holds true for a scaling triangle. This angle here can be an acute right triangle equal to 90 degrees, or an obtuse angle greater than 90 degrees. So just to re-explain that one more time, for a triangle to be acute, all angles are less than 90 degrees. And for a right triangle, to be a right triangle, you need to have at least one angle to be equal to 90 degrees. And for a triangle to be obtuse, you need to have at least one angle to be greater than 90 degrees. Okay. Guided practice. Classifying a triangle by angle measures. Okay, so I know that the total measure of a triangle is 180 degrees. So 60 plus 4x x would equal to 30 degrees. So 2 times x, 2 times 30 is 60. The same goes for this one. So since all three angles are equal to each other, we call this an equilateral triangle. This is also called an equiangular triangle or acute triangle. But I would like you to write the most specific name. Equal means all sides equal, all angles equal. Okay. And here we have 80 plus 4x plus x equals 180 degrees. 5x, x equals 20 degrees. 4 times 20 is 80 degrees. Okay, so we have two angles equaling to each other, so the opposite sides are also equal. So we call this an isosceles triangle. And since this angle here is an acute angle, as well as this angle here and this one, we can also say this is an acute triangle. But I would like you to write the most specific name, okay, because if you call this an acute triangle, this one acute and this one acute, then they will have the same name, and I wouldn't be sure if you're saying, are you referring to the equilateral acute triangle or isosceles acute triangle? And now we have the third one, x plus x plus 25 plus 25 equals 180. Okay, so 2x plus 50 equals 180. Subtract 150, 30, 65. So x is 65 degrees. 10. Oh, this is a right triangle. So we can say this is a right triangle. You want the most specific name possible. So if it's not equilateral, it's not isosceles, it's not scalene, then you have one more name for it, the right triangle. And since this is a 90-degree angle, it can't be an acute triangle, and it can't be an obtuse angle. Okay, part B, let's take a look at problems with no pictures, and you got to find the unknown side lengths. Well, you will have to be the one drawing the picture now. The perimeter of an equilateral triangle is 42 meters. Find the length of each side. So we know that for an equilateral triangle, all sides are equal. All angles are equal. The perimeter is the distance around the shape. I can let one side be x, and since by definition of an equilateral triangle, all sides are equal, then all three sides can be x. So 3x equals 42. Solve for x. X is 14 meters. You don't have to write 14 3 times. Okay, the perimeter of an isosceles triangle is 14 meters. So we have an isosceles triangle. So by definition, an isosceles triangle has two opposite angles equal to each other. If opposite angles are equal to each other, then their opposite sides are also equal. So the perimeter is 14. I'll write that down right here. The length of one side is 4 meters. The length of the other two sides are equal, so it must be referring to these two sides that are equal. So I'll put it let that be x and x, and this must be 4 down here. For the length, find the lengths of the other two sides. Okay, so 2x plus 4 equals 14. So it'll be 5 meters. Part C, finding angle measures using a ratio. Okay, the ratio of the angle measures of a triangle is 1 to 3 to 5. Find the angle measures, then classify the triangle by its angle measures. Okay, so 1 to 2, 3 to 5. Okay, so all we have to do is x plus 3x plus 5x equals 180 degrees. Okay, 9x so the smallest angle must be 20 degrees. The next biggest 60, and then 5 times 20 is 100 degrees. Okay, so this is less than 90 degrees, less than 90 degrees, but 100 is greater than 90 degrees. For if you have an angle that is greater than 90 degrees for a triangle, so this triangle probably looks like this. So this is 20, this is probably 60, this is 100, and this is greater than 90 degrees. Then we call this an obtuse triangle. The ratio of an angle measures of a triangle is 1 to 1 to 1. Find the angle measures, then classify the triangle by its angle measures. Okay, so again, x plus x plus x, because it's all ones here. So 180 degrees, 3x equals 180, x equals 60. So all the three angles are 60. So we have an equilateral, or in other words, equiangular triangle. Now one more problem. The ratio of the angle measures in a triangle is 654. Find the angle measures. Okay, so Again, x would be our smallest angle measure. 5x plus 4x equals 180 degrees. 15x x 12. Okay, so 6x, 6 times 12, 72 degrees. 5 times 12, 60 degrees. 4 times 12, 48 degrees. And then these are all less than 90. So we have a, and they're all different. So it cannot be an equilateral triangle. Nope. Cannot be a isosceles. If it's an isosceles triangle, you need to have at least two angles equal to each other. Since all angles are different, so we could say this is a scalene triangle. This is also an acute triangle, but it's not specific enough. Okay, so I want this answer. And that ends our lesson.